Hello again. So here we've got a more complicated toolpath, which goes around the entire boundary of all of the edges on this particular workpiece. And I've already gone through all of the work of setting this up in the axis map previously, so we can take a good look at what the fully optimized path looks like. And then we're going to try regenerating this same approach from scratch, but to illustrate that through repeated iterations of using the axis map to try and minimize the amount of interactions, you can actually find clear paths that weren't originally visible or available to you. So if we take a look now, and we go into the axis map, we can see that initially this looks fairly simple. However, the lean and lead angles start to get a little bit more complicated, and here we've got some very tight passes that have to be made to avoid any kind of intersection with the workpiece. However, this entire process does currently work. It's been proven and tested. So as we can see, the robot's moving around at some very strange angles to be able to get its way around the entire path without damaging or affecting or hitting anything. So let's try building this again from scratch, shall we? So if we go to set a new operation, 6D contouring, and we go to job assignment, and we grab that entire exterior contour, and then set this as a 5D curve. Okay, we can already see how the robot's kind of best guessed its way through most of it, but there's a few bits that aren't gonna be quite right there. So if we generate this toolpath, and you can see from the links and leads that are coming up here, we've already got a few problems, as well as the red status here. So we go into the axis map to try and diagnose what these issues are. So at the moment, we've already got one complaint of a collision, straight off the bat. So if we turn on collision detection and build the map, and we just give it a couple of seconds to do so, we can see straight away that there is what seems to be an automatically impassable route here, and this, on the face of it, would make many people think, well, I need to rebuild the entire toolpath then, don't I? But the fact of the matter is you don't. Okay, this is indicative of the problems in the current toolpath, but if we can eliminate as many of these problems as possible, we may be able to find alternate approaches. So let's take a quick look at the same graph renderings for the lean angle and lead angle to see if there's any obvious gaps that we can exploit. So we build the map again. And there's nothing immediately visible here. We can traverse a lot more of the early part of the path than we could before, but there's no escaping this large section right now. So again, with the lead angle, we build the map to see what it produces for us. Okay, so this is slightly more promising, but only slightly. However, we're going to do something that ENCY's axis map itself would not automatically suggest to you, because it requires a certain amount of human intuition, which is very hard to program for. And we're going to kind of brute force our way past this a bit. So if we go back to the original axis A6, and we forcibly draw a curve here by double clicking. So yes, it's now telling us there are more collisions. Okay, we'll take that. And we'll move up here. And we'll set a point here as well, so we can move up past that out of reach problem. And then, sorry, introduce more points than I intended there. Come back down. And that runs us clear. So it does tell us there are more collisions going on at the moment, but it also gives us a point A to point B graph there. Okay, so we're going to update the toolpath now. This does mean that any of the other graphs that are generated are now invalid and have to be regenerated, but it does also give us the opportunity to take a look at alternate tweaks that we can make. So if we go back into lean angle now and we rebuild the map, you'll see that all of a sudden it's changed quite drastically now. If anything, it's actually given us a pretty clear path to work through. There are some tight corners here, but there is a point A to point B clear traversal available to us. So much so that we can actually use the automatic tools at this point. So we click on build graph at this point, and suddenly we've got access. So we're going to update this toolpath now, and let's just quickly preview it. So you can preview it by moving this playhead across, as I've previously demonstrated. Okay, and there's a certain amount of pretty wild movements going on with the robot, but there's nothing there that indicates collision or a problem. We can continue to refine this, so let's take a look at the lead angle as well, just to see if there's a smoother path at our disposal. Well, all of a sudden, we've got a very, very clear path directly along the 0 degrees of deflection line. That looks pretty ideal to me. So if we click on Build Graph now, we've got this nice, neat graph. We can update that toolpath, and we can probably even get a slightly different result through the axis A6 now. So we rebuild this just to take a look-see at how it's changed. And it's changed a little bit, not as much as I'd hoped, but there is still a very, very clear and obvious route through that we can now use the automatic tools to define. So if we click on Build Graph at this point, you can see there's now a much, much smoother arc along there, which probably involves slightly less visible flailing on the robot's part, which is always good. So if we now update that toolpath and we sweep the playhead along here, we can see that yes, the head is tilting a fair bit, and if we pan out a little bit, the robot is moving around, but 90% of the work is happening in the wrist joints, which is where it's meant to be for this sort of thing. And that basically shows how, with a couple of simple steps, you can easily get your way through an otherwise seemingly impossible toolpath. Now, obviously, this is a very, very simplified version of doing this, and it's a process that I've gone through on multiple more complex programs as well. However, the amount of time that you have to put in to be able to continue redefining that axis map does entirely vary depending upon the program that you're trying to build. I'm not saying that it's an absolute 100% surefire way of resolving every problem you'll ever come across, but it is a very, very useful and powerful tool to keep in your back pocket for when you need it. As such, I really, really hope this short sequence of videos has been of use to you and will continue to be of use to you going forward on your ENCY journey. I know that learning this certainly saved me an awful lot of time and stress in the past with various machining projects of my own. Anyway, thank you for your time. Take care.